All right, so for this review for these solutions, I'm going to go through the solutions for all of them except for the problems that are on homework 10. So the problems on homework 10 are 7, 8, 16, 22, and 24. So I'm not going to go through those problems, but I will go through all of the other problems on the review. The answers to these problems are also at the end of the document of the one that's uploaded, but these are the full solutions. All right. So for this first guy, we can't just integrate him outright, but we can simplify this using some algebra. So I'm going to go ahead and rewrite these in their exponent form. On the bottom we have x to the 3/4 dx. And then when we simplify, we are distributing this denominator to all of them and subtracting the exponent that's in the denominator. So we have 3x to the 4th minus 3/4 minus 2x squared minus 3/4 plus x to the 1/2 minus 3/4. And we haven't integrated yet. So we have 4 minus 3/4, that's 16/4 minus 3, that's going to be 13/4. 2 minus 3/4 is going to be 5/4. And then 1/2 minus 3/4 will be negative 1/2, or sorry, 1/4 rather. And then I'm integrating. So if I add 1 to 13/4, I'm going to get 17/4, x to the 17/4 minus 2, and then this will be 1 over 9/4, x to the 9/4, plus adding 1 to negative 1/4, you get 3/4, plus c. And then we're going to simplify. So let's see, this will be 4 over 17 times 3 is 51. This will be 8/9 x to the 9/4 plus 4/3 x to the 3/4 plus c. And keep in mind, just kind of quick mental math here, this is the same thing as 3 times 4 over 17, which gave me a let me just fix that answer there. This should be 12 over 17, which is my bad. 12 over 17, x to the 17 over 4. The rest of these are right. I just did that mental math very wrong in my head. So there you go. So you could do that with each of these. You could just multiply by the reciprocal instead. So this is 2 times 4 over 9, which is where you get 8 over 9. And then 1 over 3/4, the same as just 4/3. For number 2, we have a similar idea to number 1. We can't just outwardly integrate it. We have to simplify it first. So I am going to go ahead and first rewrite this with the exponent form. And then I am foiling. So 1 times 2x to the 1/2 is 2x to the 1/2 plus x minus, this will be 2x to the 1/2 plus 3 is going to be 7/2. Oops. X to the 7/2. X cubed times x is x to the 4th. Right, and now I can integrate. So 1/2 plus 1 is 3/2. X to the 3/2. This will be 1/2 x squared minus 2, 1 over 9/2 x to the 9/2. 1/5 x to the 5th plus c. And then simplifying, this will be 4/3 x to the 3/2 plus 1/2 x squared, c minus 4/9 x to the 9/2 plus 1/5 x to the 5th plus c. for number 3. This guy right here should remind you of 1 over 1 plus x squared dx, which is tan inverse's antiderivative. So when we integrate, the antiderivative of e to the x is just e to the x. Now with this guy, this is the same as there just being like an 8 out front here, because having an 8 in the numerator is the same as the 8 just being off to the side there. So this would be minus 8 tan inverse x plus c. All right, so this one is going to be our first definite integral. Something I want to mention with this one, this cosine x over 4 is the same thing as 1/4 cosine x. And it can be easier to write it like that. So I'm going to integrate. So I have sine goes to negative cosine, so negative 3 cosine x. Cosine goes to positive sine, so this is 1/4 sine x, and it stays negative. So because he integrates to positive sine, since he had a negative, the negative will stay. Plus 4x, evaluated from 0 to pi over 3. So plugging in pi over 3 first, we have negative 3 cosine of pi over 3 minus 1/4 sine pi over 3 plus 4 times pi over 3. And then we plug in 0. So subtracting our lower bound. So this will be negative 3 cosine of 0 minus 1/4 sine of 0 plus 4 times 0. Oops. So then we'll have negative 3 cosine of pi over 3 is going to be 1/2. Sine of pi over 3 is going to be root 3 over 2. This will be 4 pi over 3. Cosine of 0 is going to be 1. And then sine of 0 is 0. And then 4 times 0 is 0. So let's see, we have negative 3/2 minus root 3 over 8 plus 4 pi over 3. And then this would be minus negative 3, so that's going to be plus 3. And something to keep in mind here, we can only combine 2 of these terms together. So this term here and this term here are the only terms that can be combined. So 4 pi over 3 and root 3 over 8 are not like terms. This one because it has a radical and this one because it has a pi. So I can do negative 3/2 plus 3, and that's going to give me 3/2. So I have 3/2, and then I'll leave the rest alone. And that will be my final answer. As far as an approximation goes, we can plug that into our calculator real quick and get an approximation. On a test, I do want you to give exact answers unless it says specifically to give a decimal approximation. So if it says to round to like 2 decimal places, then you can round. But other than that, give exact answers. So this would be 5.47-ish. And that's that one. For number 5, I want us to remember that we had some fun rules. In particular, we had this rule for e to the ax plus b dx. And we said that this comes out to be 1 over a e to the ax plus b plus c. Now, you don't have to actually, you can do u sub on this and you'll get this answer, but I gave you this rule so that you wouldn't have to do u sub in some of these more basic situations. So you could do the full u sub here and you'll end up with the same answer, but I'm going to use this rule because we have it. So here, a is equal to negative 4. So this will be 1 over negative 4 e to the negative 4x plus c. All right, so this is going to be our first, for number 6, our first u sub definite integral. So for this guy, because we can't integrate this outright, if you have an e raised to a crazy exponent, typically your u is going to be that exponent. So I'm going to do negative 3x squared plus 8x as our u. Our du will be negative 6x plus 8 dx. If we solve for dx, we have 1 over negative 6x plus 8 du. Our upper bound was 2, so x was 2. So if we plug x into this u formula, so you have negative 3 times 2 squared plus 8 times 2. That'll be negative 12 plus 16. That'll be 2. So it doesn't change. For the bottom bound, we have 0. Sorry, just looking at this and realized I was, my mental math was wrong there. This should be 4. Negative 12 plus 16 would be 4. There we go, fixed. The bottom bound, this one is going to end up being 0. There we go. So I'm going to leave this negative 3x plus 4 alone, and we have e to the u. And then our dx changes into 1 over negative 6x plus 8 du. And you'll notice that these don't automatically cancel. So we're going to have to do a tiny bit of algebra here. So I have this negative 3x plus 4 e to the u, and in this denominator, I'm going to factor out a 2. When I do that, I have negative 3x plus 4 left over, and that will allow me to cancel out these. So I have a 1/2 out front, integral from 0 to 4, e to the u du. Right? And I'm integrating e to the u, and when you integrate e to the u, it's just e to the u from 0 to 4. So we have, plugging into e to the u for 4, we have e to the 4 minus e to the 0, and e to the 4 can't be simplified at all, but e to the 0 is going to be 1, so this will be e to the 4 minus 1 on the inside, and there's no combining that I can do, so that'll be my final answer. Both 7 and 8 are problems on your homework, so I won't be doing those ones, but I will go for number 9. So this is a situation where we have some stuff inside of a radical, and typically when you have stuff inside of a radical, you're looking at doing u sub with letting u equal the stuff inside the radical. So 4t squared plus 12t. The du would be 8t plus 12 dt. And then 1 over 8t plus 12 du. So I have 4t plus 6, square root of, now this is u, and then multiplied by dt gets replaced with 1 over 8t plus 12 du. So we have 4t plus 6, and then this is u to the 1/2. On the bottom, once again, since these don't directly cancel, I'm going to pull out a 4 down here again. That's going to work again. Or not a 4, a 2. You can pull out a 4, but if you pull out a 4, it's not going to cancel, so you'll have to pull a 2 out of him. So I'm just going to pull a 2 out, because if I pull a 2 out, then this will identically match. So 4t plus 6 du. I'm going to pull that 1/2 out front, and these 4t plus 6's will cancel. So I have u to the 1/2 du. When I integrate, adding 1 to 1/2 is 3/2. So I have 1/2 times 1 over 3/2 times u to the 3/2 plus c. 1/2 times 1 over 3/2 is going to be 1 over 3. And then I'm going to replace u with what my u originally was, which was 4t squared plus 12t. raised to the 3/2 plus c. All right, for part 10. So looking here, this looks to me like something that's gonna need u sub because I have stuff inside cosine. But this guy right here, this is just tan inverse. So I'm going to focus my energy on just him, and then I'll come back and do the entire integral. So I'm just going to take this guy and just focus my energy on him. So I'm going to let my u be the inside of cosine. My du will be 2x dx. My dx is 1 over 2x du. And then I have x, cosine of this will now be u, times 1 over 2x du. So this x here and this x here will cancel. The 1/2 can be brought out front. Cosine integrates to positive sign, so this is 1/2 sine u plus c, and then replacing the u with x squared plus 1, we have 1/2 sine x squared plus 1 plus c. So that's this portion here. So if I do this entire integral, it'll come out to 1/2 sine x squared plus 1. Now I'm going to not put the plus c, I'm just going to put the plus c at the end. So I have that portion. For this guy, that one is tan inverse, so plus tan inverse of x plus c. So this one's kind of tricky, and it does need to be split into 3 different parts. So I'm going to write this as tan x dx, that integral, plus the integral of sine x over cosine squared x dx, plus the integral of 13x e to the x squared dx. Now, this guy right here, tan x dx, on the very last day of class, we got some integrals for that. So he has the antiderivative ln of absolute value secant x. Right? That's just flat out his integral. For the sine of x over cosine squared x, it's time to kind of think about some of the trig that we know. So sine x over cosine squared x is the same thing as sine x over cosine x times cosine x. And you kind of want to be on the lookout for situations like this. You might think u sub, and you could try u sub and see if u sub gets you anywhere. But if you're tricky, this can be a little faster. So this could be written as sine x over cosine x times 1 over cosine x. Sine x over cosine x, that's tangent x. And 1 over cosine x is secant x. So this is really the integral of tan x secant x dx. And that's the antiderivative of tangent x secant x is secant x. Finally, for this last guy, we are going to have to use u sub again. So whenever you see stuff in the exponent of e, typically it's u sub. So we'll have u equal x squared. Du will be equal to 2x dx. Dx is equal to 1 over 2x du. So we have 13x e to the u times 1 over 2x du. This x and this x cancel. You are left with a 13/2 that can come out front. His antiderivative will be 13/2 e to the u plus c, which is 13/2 e to the x squared plus c. And since we're at the very end of the integral, we can put the plus c there. And there it is. For part 12, we're going to go back to the rules that we had talked about a while ago. So we talked about cosine of ax plus b dx, sine of ax plus b dx, and then, like I mentioned earlier, e to the ax plus b dx. We had said this one was 1 over a e to the ax plus b plus c. And then each of these are very similar. So cosine integrates to positive sign. So this is 1 over a sine of, just leave the inside alone. And this will be negative 1 over a cosine ax plus b plus c. And you can only use these rules if it's something linear on the inside. So if it's like 1/4 v or 5v or 5v plus 1. But if there's like a square in here, if there's like an x squared, you can't use these rules. But in this case, we can use these rules. So here, the a is 1/4. For this guy, the a is 101. And for sine, the a is 5. So when we integrate, cosine is going to be 1 over 1/4 sine of 1/4 v. Then we have 1 over 101 e to the 101v minus 1 over 5. So this would be minus negative, so this turns to a plus sign because sine integrates to negative cosine. Cosine 5v plus c. And I'm just going to simplify this 1 over 1/4 to 4 sine of 1/4 v plus 1 over 101 e to the 101 v plus 1/5 cosine 5v plus c. All right, for number 13, this one's kind of one where you have to try some things out. So when I'm looking at this, I'm thinking, okay, probably u substitution. And oftentimes, if we can make our u be the more complicated thing, because I'm looking at this denominator, I don't want it to be this entire denominator, because that would have to, then I'd have to do product rule in my u sub, and that tends to not work. But I see this square root w plus 1, and I think, well, that's a little more complicated than the square root w, so maybe I'll use him as my u and just kind of see where it goes. So I'm going to let u be, and I'm going to write this as w to the 1/2 plus 1. So my du is 1/2 w to the negative 1/2 dw. And prior to me rewriting this, I'm going to just rewrite my du. So I haven't rearranged anything here. 1/2 w to the negative 1/2 is the same thing as 1 over 2 square root w dw. So when I solve for dw and I flip that fraction upside down, I have that dw is equal to 2 square root w du. So I have this 5 up here, I have this square root w, and now I have a u times 2 square root w du, and this square root w and this square root w will cancel. So I have 5 times 2 is 10. I'll just put him out front. 10, 1 over u du. Well, that's ln right there. So I have 10 ln absolute value of u plus c. And then u was square root w plus 1 plus c. You could also write that the inside part as w to the 1/2 plus 1, but I figured I'd just make it nice. All right, number 14 is going to be another one where you have u sub with a definite integral. So if there's something nasty in the denominator, and this is different than, oops, let me scroll backwards. This is going to be different than number 1, where we only had one thing in the denominator, so we could split it up. We had one term. Here we have multiple terms in the denominator, so we can't split it up and simplify. So we're going to need to do some u sub, and typically the u sub you want to do is let the denominator be your u. So I'm going to have u equal x cubed plus 1. My du will be 3x squared dx. Solving for dx, I get 1 over 3x squared du. My top bound is 4, so x equals 4. That means my u value would be 4 cubed plus 1. So that's going to be 65. My bottom bound is 0, so I have x equals 0. U is going to be equal to 0 cubed plus 1, which is 1. And then, let's see, I have an x squared up here. The denominator becomes u, and then dx becomes 1 over 3x squared du. So this x squared cancels. I'm going to take the 1/3 out front, going from 1 to 65, 1 over u du. 1 over u, that's ln absolute value of u, from 1 to 65. And remember, we're not plugging u back in because we have a definite integral. So this is 1/3 ln of 65. I don't need the absolute value because the absolute value of 65 is 65, minus ln of 1. Now ln of 1 is just 0. So this is just 1/3 ln of 65. And that would be our answer. All right, number 15 is, surprise, surprise, going to be another u sub situation. So we have some stuff on the inside of a large exponent. So typically we want to do u sub there. So I'm going to let u equal x cubed plus 1. My du is going to be 3x squared dx. Dx is going to be 1 over 3x squared du. So I have the integral of 5x squared u to the 6th times 1 over 3x squared du. The x squareds will cancel. I'm going to bring the 5/3 out front. U to the 6th du. Right. Integrating, we have 5/3. This will be 1 over 7 u to the 7 plus c. So we have 5 over 21, and then u to the 7th, so this will be x cubed plus 1 raised to the 7th plus c. For number 16, we're skipping that one because that one's part of the homework. So I'm going to number 17. Now, when I look at this one, I notice something immediately. I know that the integral of tangent x secant x dx is secant x plus c. So I kind of see what this could be here, but there's a y squared in there. So to me, this screams u sub, and let y squared, because it's the inside, be u. So u is equal to y squared. My du is equal to 2y dy. dy is equal to 1 over 2y du. So we have this y out front. This is tangent of u, secant of u, times 1 over 2y du. This y and this y down here will cancel, and I will bring that 1/2 out front. Tangent u, secant u, du. That integrates to secant u plus c, so 1/2 secant u plus c. And that'll be 1/2 secant of y squared plus c. All right, number 18. So once again, if you have a lot of stuff inside of a radical, typically it's a u sub, and typically the inside of the radical is going to be u. So I'm going to let u equal x to the 3/2 plus 1. My du is going to be 3/2 x to the 1/2 dx, which I am going to rewrite. This is 3 square root x over 2 dx. So when you go to solve for dx, it's just that flipped upside down. So 2 over 3 root x du. So I have square root of x, square root of u, times 2 over 3 square root x du. So the square root x's will cancel. I'm going to bring that 2/3 to the outside and rewrite square root of u as u to the 1/2 du. So you have 2/3, and then adding 1 to 1/2, you have 3/2, and then u to the 3/2 plus c. This simplifies to 4/9, and then I'm going to replace u with x to the 3/2 plus 1. Make sure it's still raised to the 3/2 power plus c. All right. For number 19, another situation where if you have a lot of stuff in the denominator, probably going to be u sub, and the u is probably going to be the denominator. So I'm going to do u equals x to the 4th minus 2x squared plus 14. My du is 4x cubed minus 4x dx. And then solving for dx, we have 1 over 4x cubed minus 4x du. My top bound is 3, so if x is equal to 3, u is equal to 3 to the 4th minus 2 times 3 squared plus 14, which I'm going to plug into my calculator because I don't feel like doing that in my head. Let's see. Getting 113. And then for my bottom bound of 1, u is equal to 1 to the 4th minus 2 times 1 squared plus 14. So 1 minus 2 is negative 1, plus 14 is 13. All right. And I'm going to leave the numerator alone for a moment. The denominator is now u. And then we have 1 over 4x cubed minus 4x du. Now notice how these won't cancel directly. However, they're very close to being able to cancel directly, and if I pull a 3 out of the top, they will cancel directly. So that's what I'm going to do. So I have 13 to 113. Pulling a 3 out of the top, we have 4x cubed minus 4x all over u times 4x cubed minus 4x du. And now those cancel. I'm going to pull this 3 out front. So we have 1 over u du. So this will be 3 ln absolute value of u, evaluated from 13 to 113. And we are good to just plug in our bounds. We don't have to plug u back in because this is a definite integral and we changed our bounds. So this will be ln of 113 minus ln of 13. And that will be your final answer. And now I'm looking at the answer key and seeing that I got this number right here. It was supposed to be actually 77. So this should be 77. This should be 77. This was just me plugging in bad. So this should be 77 minus 13. And that would be your final answer. So that was just my bad. I just plugged in incorrectly up here. All right, for number 20, kind of, you know, how everything has been going. If you see something inside of a radical and it's not just an x, tends to be a u sub situation, and u tends to be whatever's in the radical. So u is equal to cosine x, du is equal to negative sine x dx, dx is equal to 1 over negative sine x du. And then we're going to change our bounds. So if x is equal to pi over 2, then u is equal to cosine of pi over 2, which is 0. If x is equal to 0, u is equal to cosine of 0, which is 1. Really, really important here. Even though it looks like the bounds kind of got weird because now it's like small to big and then big to small, don't flip them. If pi over 2 gives you 0, 0 stays where pi over 2 was. You plugged in 0, you got 1, 1 goes where 0 was. Don't flip them around. So then we have sine x, square root of u, times 1 over negative sine x du. These sine x's will cancel, and I will take this negative and I'm going to put him out front. So this will be negative 1 to 0, u to the 1/2 du. So integrating, this will be 1 over 3/2 u to the 3/2, evaluated from 1 to 0. 1 over 3/2 is 2/3, and I'm just going to kind of pull that outside. Plugging in my bounds, this will be 0 to the 3/2 minus 1 to the 3/2, which is negative 2/3. 0 minus 1, negative 2/3 times negative 1 is positive 2/3. That's that for number 20. For number 21, now this is going to be a u-sub problem. However, there's multiple directions you could go here. What I will tell you from my experience is that what tends to take precedent is anything that's in the exponent of e. So if e has a 1 over x in its exponent, that tends to take precedent and be what your u is. So I'm going to let u be 1 over x, which is x to the negative 1. So dx is equal to negative x to the negative 2 dx, which I'm going to rewrite as negative 1 over x squared dx, and then solve for du. Oops, this guy right here should have been... Okay, hold on. This should be a du. We are solving for dx here. There we go. Much better. We had a du. We're solving for dx. That's going to be negative x squared du. Just flipping it upside down. You get x squared over negative 1, which is negative x squared. So we have e to the u over 2x squared times negative times negative x squared du. The x squareds are going to cancel. We can pull the 1/2 out front. This will be e to the u du. Negative 1/2 comes out front because there's a negative right here. Then we have negative 1/2 e to the u plus c. Negative 1/2 e to the 1 over x plus c. And there's that one. Right. Number 22 is part of the homework, so I'm not going to do that one. So I'm going to move to number 23. And for this one, we're going to try to find f of x using the initial conditions given. So this is the same idea as integrals. It's the idea of antiderivatives. The antiderivative of f prime of x is f of x. So I'm going to start by rewriting f prime of x. This is negative x to the negative 2 minus 3x to the negative 4 plus 12. And really what I'm doing here is I'm integrating f prime to get f of x plus a constant. So I'm going to have to solve for this constant using the initial condition. But the idea is if you integrate this, then you can figure out what that initial f of x function is, because integrating kind of gets rid of that derivative. So f of x, if we integrate, this will be negative, adding 1 to negative 2, so that's negative 1, so 1 over negative 1, x to the negative 1 minus 3, add 1 to negative 4, you get negative 3, so 1 over negative 3, x to the negative 3 plus 12x plus c. So that becomes x to the negative 1 plus x to the negative 3 plus 12x plus c. That's what f of x is. We need to solve for c, and we were told that f of 1 is equal to 3. So if we plug in 1 for x, 1 to the negative 1 plus 1 to the negative 3 plus 12 times 1 plus c, 3 is equal to 1 plus 12 plus c, 14 plus c. So c will be equal to negative 11. So we just need to take this negative 11 and plug it back in for c, and we have our f of x. And if we wanted to be really fancy, we could rewrite this as f of x equals 1 over x plus 1 over x cubed plus 12x minus 11. And both will be the same answer. All right, number 24 was also a homework question. So number 25 is our last question here. And we're going to be doing the same idea. We're going to take antiderivatives to kind of work our way back up to find f of x. So this first antiderivative we can find would be f prime, because we go from f double prime to f prime. And we're doing an antiderivative here. So this will be 12 times 1/3 x cubed plus 6 times 1/2 x squared minus 4x plus c. So 4x cubed plus 3x squared minus 4x plus c. And normally at this time, we'd have an initial condition we can use, but notice that none of these initial conditions involve f prime at all. So I can't use any initial condition. I'm just going to have to leave that c alone and go on to the next step. So I'm going to find another antiderivative. I'm going to f this time. So I have 4 times, this will be 1/4 x to the 4th plus 3 times 1/3 x cubed minus 4 times 1/2 x squared plus cx. And now since I've already used c as a variable, I'm going to use d as a variable. And I'm going to simplify. So we have x to the 4th plus x cubed minus 2x squared plus cx plus d. And now I can use both of these initial conditions. So I'll start with f of 0 equal to 4. So when I plug in 0 for x, that'll be equal to 4. So 0 to the 4th plus 0 cubed minus 2 times 0 squared plus c times 0 plus d. I get 4 is equal to d. So this guy right here is 4. Let's make that look more beautiful. 4. Then I can plug in my other initial condition using the information that I had, that d is 4. So f of 1 is equal to 1. So if I plug in 1 to the 4th plus 1 to the 4th minus 2 times 1 squared plus c times 1. And then we know d is 4, so I'll plug in 4 there. So let's see, we have 1 plus 1 is 2, minus 2 is 0, plus 4, so 1 is equal to c plus 4. So c is equal to negative 3. So we can plug those both back in. We get f of x is equal to x to the 4th plus x cubed minus 2x squared minus 3x plus 4. And that is our final f of x. And that is it for this review. So like I said, the problems that are on your homework, those 5 problems I did not do. Those ones are for you to do. But this is all of the other ones. If you have any questions, let me know. Send me an email. Otherwise, good luck on your studying.